So now I'm going to cover some of the design standards and criteria, really getting into those layers and the requirements of those bioretention layers. So that first one, 2 to 3 inches of mulch, compost, or landscape rock. This is actually a pretty important layer. It seems like it would just be for aesthetic purposes, but most of your heavy metal treatment is going to come in that mulch or compost layer. Obviously, the option of landscape rock isn't going to treat any heavy metals, but depending on the area, maybe you're really concerned about flotation of mulch during flooding events, then landscape rock is an option, but it's not going to give you that heavy metal reduction. Mulch also helps with preventing compaction. Due to heavy storm events, your soil could get compacted, and mulch is going to provide a protection for that. It also prevents weeds from growing in your bioretention area, which can be of benefit, especially to the landscape maintenance. And then it'll also protect against erosion from that. It's kind of your last flow spreader to make that sheet flow as it's going into your bioretention area. So the standards for mulch are pretty simple. There's no, really ASTM specifications for mulch. So they say commercially available, double or triple shredded, and screened hardwood mulcher chips. The hardwood mulch is going to be less likely to float than other types, especially other than pine or straw or grass clippings as a mulch. And you screen it so you get some of those fine particulates out of there so that's not clogging up your filter media, your soils. They said no soil or fine organics. Again, that's to keep it from getting clogged. They should be stockpiled or stored for 6 to 12 months. A lot of people require a minimum of 12 months. And that's again to settle it out, to kind of age it and make it a better habitat for some microorganisms that'll help you get some more biological treatment in your media. And then uniform in color. That's to keep it looking nice, and then also to make sure it's the same type of mulch throughout. Are there any questions on mulch? The compost that is also that can be an option is usually a leaf compost. So if you're looking at those, it's mulch, leaf compost, or landscape rock, but probably only in areas where you're not worried about metal movements. So the next one is the engineered planting soil. This isn't just the soil that's around there. You do have to have it brought in. It is engineered, specified soil. The 2 to 4 feet, that's going to be dependent on what you're planting. There's usually a minimum of 2 feet for filtration purposes, but then if you're going to plan to have trees or larger shrubs and bushes on there, you're going to want 3 feet to 4 feet for some of the larger trees. Located on A or B soils where possible. If you have areas where there's A or B soils, maybe you won't have to put in an underdrain. That'll save substantially on your cost for the bioretention pond.
How about D soils?
Yeah, I know that A and B are few and far between in this region, but and that's why there is an engineered soil, so you can build these on D soils, and then you can get some filtration treatment. You want to make sure it's free of stones, lumps, or roots larger than 2 inches. Also any weeds or anything like that might grow in the medium. If this soil should be sandy loam, loamy sand, or loam texture, what that usually looks like is sand content of 50 to 60%, leaf compost content of 20 to 30, topsoil content 20 to 30, clay content 5 to 8, and then organic content such as peat moss of 1.5 to 3%.
What was your clay content?
It's 5 to 8%.
Is there a list of trees?
Yes, I will get to the landscaping.
Is there information on that in the COG technical manual?
There is, some of this is in the COG technical manual, and some additional requirements as well, such as potassium and magnesium. That's going to be found under the landscaping technical manual. So I mentioned before, a lot of this data is in the site development controls section of the technical manual, but there's also a landscaping manual on the website, and that's where you're going to find a lot of the mulch and planting soil specifications. So engineered soils, I mentioned, should have an infiltration rate of at least 0.5 inches per hour, but typically they're higher than that. The 0.5 is to account for design and to be conservative. Usually you'll find 1.5 or higher inches per hour. The pH is important. It should be between 5.5 and 7.0. Maximum soluble salt concentration of 500 parts per million. Uniform mix, and the tests that we see that are most common to be performed on engineered soil are a sieve analysis, a pH test, and an organic matter test. Those are the three main ones. So, and then the phosphorus index between 10 and 30. Phosphorus is another important factor that you want to look at, because a lot of times what they find is that if people don't pay attention to the phosphorus level, then what you're getting out of your bioretention pond could have a higher total phosphorus than, you know, the runoff if you hadn't treated it at all. So if you have a soil with a really high phosphorus level, then that can be worse for that pollutant, that particular pollutant, than if you hadn't done anything. So here's a table of engineered soil standards. This is actually from the Charlotte manual. A lot of the numbers are very similar to what's in the ISWIM manual, but I do like this, that it gives you a sieve analysis, so that's very useful. And then there's a couple of standard ASTM numbers that they give you as far as specifications are concerned. And that TMECC stands for testing methods for the environment of composting and compost, I believe. So the next layer is the filter fabric. There's a couple of different options here. The first option is obviously to just have a filter fabric cover your entire base, and then it would also cover the side walls as well. That's to prevent any infiltration into, into these side soils. You want to keep that water moving laterally so it's not going under your pavements, causing problems by getting water under your driveways or roadways. The alternative is, instead of having filter fabric all along the bottom, you put in a choking stone. This is going to serve as just another layer of filtration. It's usually a pea gravel of about 4 to 9 inches deep, and that pea gravel is going to serve kind of the same purpose as the filter fabric, but where you have your underdrain pipe, if you do have an underdrain system, you are going to still want to put in about 2 feet width of filter fabric above your pipe. And that's just to make sure those last really fine particulates don't start clogging up your pipe. So, placed over the gravel layer and along sloping outer walls to limit infiltration before filtration and prevent lateral flow. Filter fabric shall be non-woven, so typically just a geotextile, and a minimum permittivity rate of 75 to 125 gallons per minute per square foot, which is just kind of standard for filter fabrics. You'll find that information on them. And then some testing methods and other requirements for geotextile properties, to deal with trapezoidal tear, permeability, ultraviolet resistance. The last layer there is that 6 inches to 1 foot of gravel. This is going to be a slightly larger gravel than that choking stone layer. The purpose of it is to create positive drainage. It's going to flow through that area a lot faster, keeps the underdrain free of sediment, provides aerobic conditions in the planting soil, and is kind of a final polishing treatment before you're getting it into that underdrain. The gravel is typically number 57 stone, inch to an inch and a half, or half an inch to inch and a half. double wash to make sure you're getting rid of any fine particulates before you're installing it. Specifications and the drawdown, what we found is a lot of manuals specify 72 hours of getting it through that washed gravel layer. So that's not the ponding drawdown limit, that's actually when it's all through the gravel and has gotten into your pipe. And then there's a SIP analysis down there for typical number 57 stone. Then the underdrain layer, this is, in these regions, you're most likely going to need an underdrain layer. So we have 6-inch perforated PVC pipe, rigid schedule 40, common specifications for just perforated PVC pipe. Perforations, standard 3/8-inch perforations, spaced 6-inch centers. The pipe spaced at a maximum of 10 feet on center, minimum grade of 0.5%, and you assume 50% loss in capacity due to clogging. I also wanted to cover some underdrain cleanout requirements. Those are going to be the pipes that are coming up and sticking up in your bioretention area. They should also be 6-inch solid PVC cleanouts. We recommend every 50 linear feet or at all bends or at the ends of the system. So, top of cleanouts should extend 6 inches above maximum ponding elevation. You wouldn't want it below your ponding elevation because if that gets clogged out, if your pipe's getting clogged while there's a flood event, you still want to be able to get to that pipe and flush it out. One clean out installed is emergency drain, even with top of mulch layer with a 6-inch threaded extension pipe. That's an optional requirement. You have your overflow inlet that'll be catching most of the extra runoff or the flood runoff. So if you want some extra protection, then an emergency drain.
So you're saying this is a vertical lateral, and then it bends and goes to the inlet?
No, this is just sticking up, and the emergency drain would be level with the mulch layer. So it could just be opened if you need to drain it faster than if you have your flood control inlet, but that's going to be a little bit higher than your mulch layer. But if for some reason you need to drain that bioretention pond right away, then you'd be able to lift that cap off and it would go into that emergency drain.
Do you want it set below the mulch layer?
Well, just at the mulch layer.
Oh, actually, okay.
Yeah. And then all cleanouts to have watertight vandal-proof caps. So, and then a little bit about the landscaping standards. There is, again, the landscaping section of the technical manual that has a whole bioretention section with a large list of trees and plants and shrubs. These are actually pictures of plants on that list for bioretention pond, so they don't have to be hideous. You can have a fairly aesthetic bioretention pond. And they recommend a tree to shrub ratio of 2:1 or 3:1 if you're going to include trees. It should be fairly dense, but not overly vegetated. Trees placed up to 8 feet apart, and plants should be resistant to drought and inundation. Here's that list. This comes directly from the ISWIM landscape manual. You got trees, shrubs, and herbaceous species, the scientific name as well as the standard name. And then after each one of these, you'll see a zone with a number behind it. Those zones tell you what area of the bioretention pond it's recommended for planting. There's a list of the different zones and kind of the hydrologic conditions that they're expected to receive. And then down there's a map. So zone 3 would be kind of the very center of that bioretention pond. Zone 4 is going to be the outer layer. And then zone 5 and 6 would be mostly where your grass area is. So with that, I will hand over to Mike Wilkins for maintenance and inspection.